Okay, problem is now you're told that Y is the last milepost you passed as you're traveling along Interstate 81. Traveling northeast actually, along Interstate 81. And T is the time since you started. T is measured in hours, and Y is measured in miles. Okay. So we do a graph of Y versus T. Now, it could be Y versus X, but we often do Y versus T because often we're talking about something that changes in time. So we don't have to call this the x-axis, it's the t-axis. I could have let x equal the time, that's okay, but letting t equal time is a little more, connects us a little better to the meaning of what we're doing. Okay, so now the first thing I asked is, okay, you got point 3, 190 on this graph. What does 3, 190 tell you? Okay, you have to be able to look at a graph that has a meaning and tell me what the coordinates of a point reveal about whatever it is that's happening. Now you're going up the interstate. What does 3, 190 tell you about your trip up the interstate? Well, 3 is your first coordinate, that's this, and 3 then is a time since you started in hours. So that means this is 3 hours after you started. Okay, so this point represents something that happened 3 hours after you started. Okay? Now, what's the 190 coordinate tell you? Well, that's the last milepost you passed. So you're somewhere, between the 190 and 191 milepost, but let's just say this means you've traveled to about mile 190. So in 3 hours, you're a little beyond mile 190. Okay? That's what 3, 190 tells you. Now you always have to, if you have a situation where you have meaning to the two axes, you always have to understand then that you want to think about what the two coordinates at any point tell you within that meaning. Okay, again, 3 tells you it's been 3 hours since you started, 190 tells you you're at mile 190. Now you might say, okay, so I've traveled 190 miles in 3 hours. So I've traveled at a little over 60 miles an hour. Well, no, you can't say that because there's no information about where you started. We didn't say that you started at milepost 0 down there between Bristol, Virginia and Bristol, Tennessee. You didn't start there necessarily. That's not part of the information you have. You could have started any place. If you started from the college, you started at exit 14, okay? If you started from home, who knows what the nearest exit to different people's homes is. Okay, but 3 hours into the trip, you're here. And then we have the point 5, 290. What does that point tell us? Well, that tells us that 5 hours into the trip, you're at mile 290. Okay? So now we have 2 points. What does the rate of change of y with respect to t? What is the rate of change of y with respect to t? And what does it mean? First, calculate what is the rate of change of y with respect to t. That is the slope of your fundamental triangle. Okay, that's the average rate of change of y with respect to t for this interval. Well, we draw the fundamental triangle, and we got room to draw it on the board. It's big enough. So we see that the run is 5 minus 3 equals 2, the rise is 290 minus 190, which is 100. So we immediately get slope is rise over run, which is 100 over 2, which is 50. Now what does that mean? And I said that fast, but that's got to be automatic. As soon as you know the 2 points, you write all that down. Don't even stop for breath. And then you stop and say, okay, what does that mean? Maybe you're more inclined to think about what it means while you're calculating. Okay, that's okay, you can do it either way. One way or another, you have to know what to do with the fundamental triangle and do it. Okay, so I've done it this way, and now we're going to kind of rewrite it, okay, with the meanings. Okay, your run is 5 minus 3 equals 2. What's that mean? Well, 5 is the number of hours since you started, 3 is the number of hours since you started, 2 is the difference in those two clock times. Your run, we could write as not 5 minus 3, but 5 hours minus 3 hours. And 5 hours minus 3 hours is 2 hours. And that is the change in our clock time, okay? And that means we've taken 2 hours to get from here to there. The rise is 290 miles minus 190 miles, and that's 100 miles. Well, that's how far we've driven, isn't it? Okay, and it's very clear. We put the miles on it and we think about what it means, and you say, oh, no, that's how far we've driven. You imagine going from mile 190 to mile 290, it'll should immediately pop into your head that I've gone 100 miles. Okay? So now we do the slope. We divide the rise by the run, meaning we divide 100 miles by 2 hours. And 100 divided by 2 is 50. Miles divided by hours is miles over hours. And of course we can read that as miles per hour. So, this is what? It's how fast we drove on the average. Now we might have stopped, we might have driven 90 miles an hour. Don't do that. We might have driven 90 miles an hour for a little ways. Yeah, maybe there's a big old truck behind us and pushing us, and we had to go 90 miles an hour. But you know, our speed could have varied, but it averaged 50 miles an hour, and this is the average rate of change of y with respect to t. And that is, of course, then the average rate of change of our position along the interstate with respect to time. Or maybe I'd call it clock time, time on a clock. An average rate of change of position with respect to clock time is what we call a velocity. It's the definition of velocity. Now you know that's a speed, you think of it as a speed, and in this case it's actually a velocity, which is speed with direction. We're going 50 miles an hour in the positive direction. We're going 50 miles an hour in the direction that increases the numbers on the milepost. If we were driving south and it was 3,290 and 5,190, then our rise would have been negative 100 miles, and our result would have been negative 50 miles an hour, meaning 50 miles an hour in the direction that decreases the numbers in those mileposts. It's kind of an important distinction, but not completely essential for this course, but what is essential is knowing the definition of the rate of change and applying it and thinking about what it means, because that's how you use mathematics to actually get new information and to think about things and to understand things more deeply.